Hello, everyone. Welcome to our session talking about emerging technology to tackling climate change, IoE solutions. I'm Qin Min Peng, the moderator today, and it's from the TCP, Taiwan Climate Partnership. TCP is, we started TCP about 3 years ago. It's from the Taiwan 8 leading company. For example, the AUO, Delta, TSMC, Microsoft, Lion, Acer, Pegatron, and Asus. And we organized together to do something about climate change because such is kind of ICT industry, the leading, they know the importance of climate change. But one can do, but together can do more. And what we did right now, we will have a session to talk about IoE. And right now I was in COP28 Blue Zone in Dubai, and right now is 3 p.m. and in Taipei time is about 7 p.m. right now. All of our speakers are online, and we are like to join us. And we have another moderator is Kevin Lin, EI head of the Lion Technology Collaborations. Hello, Kevin. Hello, Kevin. How are you? Yeah. Okay. I know that Taipei is just very cold today, and here Dubai is very very hot, and we have several speakers. And later on, I would like to invite Kevin Lin to make an introduce. And we have the Ali, Professor Ali, and the Jin Yang, and also the Su Yang, and also Anita Jian. Most of them are from the Lion and also from the Nanyang Technology University. And Anita Jian is from the Next Drive. Next Drive is a very new company and very interesting in this field. So I will give my floor to Kevin Lin to introduce all the speakers to be our moderator today. Kevin, please.
Hello, can you guys hear me? Hello.
Yes.
Kevin, the floor is yours, please.
Sure. Good afternoon and good evening, everyone. My name is Kevin Lin, the head of Efficient Infrastructure, a new product division of Lion. I will be moderating this afternoon. It is a privilege to join all in this virtual COP28 session on emerging technology to tackle climate change with IoE, Internet of Energy solution. Along Dr. Pan and my esteemed colleague, as we engage this important discourse about emerging technology and their potential to mitigate the effect of climate change, I'm honored to extend a warm welcome to all our speakers and attendees from Dubai, Taiwan, and across the globe on behalf of Lion. At Lion, we are committed to developing an innovative solution that not only enhance technology, but also have a positive impact on our environment. We believe this common goal of protecting our planet unites us all and create a shared sense of urgency to address this climate crisis. I'm excited to be part of this discussion with all of you, and I look forward to hearing from our brilliant speaker on how emerging technology combined with IoE solution can help us combat climate change and make a better future for our planet. Thank you for having me, and I wish you all a productive and insightful section. And for the first speaker, I believe we have Professor Ali from American University of Sharjah. He has a specialty in embedded and cyber physical system, hardware, software architect, smart home automation, smart grid smart grid evolution, development, and smart factory and city. I believe, unfortunately, he cannot join us in real time, but I believe he has recorded a video. Can we play the video, please?
And my name is Abdurrahman Ali. I'm from the American University of Sharjah. I had hoped that I will be present personally, but due to reschedule travel commitment, I couldn't make it. So I would like to thank the organization committee and Ms. Rose for allowing me to record my talk, and hopefully I can join online if the time allow. Otherwise, I will leave my email for further question and regarding of my presentation. My presentation is I will be talking about the today. I'll be talking about the role of Internet of Things and smart grid and smart city and virtual power plant in the UN Sustainable Goals. First of all, I introduce you to the Industrial Revolutions roadmap and what's the Internet of Things, what is the Internet of Everything conceptual model. Then I'll give you a highlight about the smart grid and smart energy within the context of the smart city and the IoT role in renewable energy resources and what are the virtual power plants and the Internet of Energy that will help the power outages crisis, and how is the IoT and the virtual power plant play substantial role in the UN Sustainable Goals and their impact on the greenhouse gas. This talk is summary of two talks I gave recently. Last September, about 2 months ago, I gave a talk in China about smart grid applications within the fog computing context, and I was the chair of the conference and chair of the conference of the 2023 International Conference on Smart Grid and Smart City. And last month in Tokyo, Japan, I chair another two conferences, which is the International Conference on Power and Renewable Energy Engineering, as well as the other conference, International Conference on Artificial Intelligence and Power Engineering. And I gave talk, and I was keynote speaker and conference chair. So basically, this is the background that I have. So what are the things? They are good objects, machine, cars, building, vehicle, people, plant, soil. And to give you an idea about it, if you look here, the car is a thing. If you connect it, it becomes connected thing with the GPS, download information to it, it will be things of the internet, upload the status of the car, the whereabouts of the car, and you communicate with the car, download and upload, and become Internet of Things. The smart meter, the thing, if you get the location of the using the GPS, it become thing connected things. And if you download the cost of per kilowatt and you communicate with it to do setting or something, it become things of the internet. And if you upload the consumer energy consumption and send it to the utility headquarter, it becomes Internet of Things. And as you see, home appliances, smart meters, you read the voltage, current, gas, water consumption, you read the switches status, recloser at the substation, you go to the manpower using their mobile, you connect them, you go to distributed energy, you connect them. So these are all things are connected to the internet. And we are going from the Internet of Things to Internet of People to Internet of Service, which is, these are the applications and the Internet of Things and Internet of Data. And then they are coming with something, Internet of X, where you have Internet of Energy, you have Internet of Health, you have Internet of Smart Light, you have Internet of Smart Grid, Internet of Transportation, Internet of Government, Internet of Farming, and so on and so forth. And as you see, then the physical layer, you have your home, energy, healthcare, hospital, you have industry, you have signages, you have automobiles, you have trains, you have just name it. All these are internet platforms and they communicate through the cloud. So all this advent and the communication and computing came about the smart city. The smart city nowadays, you could have smart energy, smart power, smart health, smart building, smart homes, smart street lighting, smart parking. All these things are connected to each other, and you ship up the data to the cloud. Now, in 2010, they came up with conceptual model for the smart grid. The traditional grid, you have the bulk generation, transmission, distribution, and consumption, the power direction generation one way, and the communication only between these domains, the generation, the transmission, distribution, and consumer consumption. The operating system, the operator can control the data between these things and control them remotely. And you have the service provider and marketing. Nowadays, all of them, they are communicating in two ways communication, and that the energy also generated in two ways, where the distributed energy, it's everywhere. At home, you see here we have distributed energy, we have storage energy, and this is the model for the smart grid, where you have your consumer has many networks, distribution many network, transmission many network, bulk generation many networks, and here is the operation. They have also their networks, including SCADA. Here you are the service provider, third party provider, utility provider, and here is the marketing. So this was really the starting of the Internet of Things and Internet of Energy and Internet of Smart Grid. Nowadays, they came up with 3 models. Here's your smart meters connected to home, smart meter connected to residential area, smart meter connected to a factory, smart meter connected to business, smart meter connected to storage and renewable energy. All these things are connected to the Internet of Things, and they ship their, you can make a little decision at home or at factory, and then you ship the data to the fog layer. The fog layer is computer centers. They are located in a parking lot, in malls, a roadway, roadside. So in the fog layer, you could do almost real-time analysis, and you send the decision down to the ground, to the edge computing devices where are the smart meter. And after you do some analysis here, you can do machine learning, deep learning, AI, and then you filter the data and you send it to the cloud for further processing and for planning for not real-time action, planning, forecasting, and so on and so forth. So what you have here, this is your edge computing, and this is the cloud. So the cloud, between the cloud and the ground, they introduced most recently such fog layer. And as you see here in the edge computing device, you could have the transformer temperature, the power consumption in the transformer, the current load, the voltage, a smart energy meter at home. You read the current, the voltage, and the power, and the line sensor where you read the voltage and the current and the active power. That's between the substation and the distribution station. And then you go to the fog layer where you can do real-time streaming analytic, outage management, transformer health monitoring. You filter the data for long time, forecasting, for balancing. You send it to the cloud, and what you can do in the cloud, you have storage of the data, you have utility bills, you have demand prediction, you have high-level processing with historical data for a lot of things at the country level, let's say. And this is the state level, the fog. And this is the neighborhood level. And basically having the cloud computing, it will give you really reduce the latency. You can do artificial intelligence. You can enhance the data privacy, decentralize computing power, decentralize energy, renewable energy, on-demand response, enhance quality, increase efficiency, user satisfaction, much more, enhance security, and then the cost. So basically, having the cloud, it's geographical partitioning, different devices and device mobility. It will know the reducing the fog computing. It will be context awareness. Where are these devices, whether they are on the move or stationary? But if you go to the cloud, rarely they know the location. And basically, you have you are promoting real-time application access end-to-end surface computing node through wireless mode. And this is the traditional grid. As you see here, this is industry, this is home. And here you have the utility business. They are or measuring the utility center. And here your utility center. And here is you collect the energy consumption from home, from industry generation. And then they introduce the cloud in between. As you see here, this is the cloud computing. You go to the cloud computing and you take all the responsibility of the data center to the cloud, and still has some disadvantage, not real time, but it has super power computing. You don't have to worry about the software license. You don't have to worry about the platforms update. You don't have to worry about the hardware update. So basically, you just rent from these cloud services, their services, just software as services, hardware as services, and platform as services, and you just worry about your generation and distribution. But this is some disadvantage with the traditional grid. With the cloud computing, it becomes smart grid. And now, to go further, they introduce between the cloud and the edge computing the fog layer. Where's the fog layer here? Honestly, it will do just what I told you just a minute ago. It will do all this process in between and send the data to the cloud. So you have 3-layer, edge layer, fog layer, and network layer. And as you see, the advantage, traditional grid, you see how much is the data rate and the network traffic, the blue. It's a lot of traffic. If you introduce the traditional grid with the cloud computing, you see here the almost the red bars. So it's much better. You reduce the data rate that you are going to transfer with. You have more traffic. And then when you have the smart grid and the cloud and the fog together, your data rate megabit, you don't send that much to the cloud. So you reduce a lot from the bandwidth. Latency is much less when you use the fog layer, and it's a little bit more when you use only if you process in the cloud. And if you just use the traditional grid, look how long it takes to process. And here, the energy consumption in the traditional grid utility data center, they consume a lot of power. If you use the cloud with it, so you reduce the power consumption. And if you use the cloud and the fog layer, you reduce the energy consumption. And as you see here, this is the percentage of enhancement using smart grid with the cloud base and fog base. You enhance the delay about 60 to 90%. You enhance the query access 30 to 20%. The power consumption, you reduce it 50 to 60%. Queries you are communicating a request also, it will be much better than 20 to 40%. The network traffic also has been enhanced 35 to 60%, and the throughput also, it will be enhanced. So now we have the virtual power plant. The virtual power plant, due to time, I'm going to skip this slide and go this slide. So the virtual power plant is a power system that refers to network, integrate various distributed energy resources. As you see, this is the traditional grid. And then this is the control center. And then you have the smart home PV generation, PV system generation, windmill generation, fuel cell generation, biomass generation, and energy management system. And you connect all this to a virtual network. And the advantage of using this virtual power network is balancing supply and demand is grid stability and reliability is better. Grid stability and reliability, optimization, asset demand response management is much better, and market participation in the virtual power plant can participate electrical markets, selling excess power generated by the aggregated distributed energy sources, or offer service like peak shaping, load shifting, or capacity reserve. Renewable energy also here, also in the virtual power plant, you will have renewable energy integration to the network, and energy trading and distribution becomes much better and much easier. Sorry. So basically, the virtual power plant, in summary, it will help in distributed energy resources coordination, flexible and scalable, demand response, and the Internet of Things. It will enhance the grid management, prediction maintenance, energy efficient, and consumer engagement and energy measurement. So basically, let's try to map the virtual power point plant and Internet of Everything to the United Nations Sustainable Goals and see their roles in the greenhouse emission. So what we have here, the virtual plant, distributed energy resource integration, and this is going to serve the Sustainable Goals number 7 and number 11, flexibility and scalability. It will enhance and serve goal 9 and 13, demand side, demand response management. It will serve goal 7 and goal 12 for the Internet of Things, enhance the grid management. And this is really, it will boil down and serve the goal 7, goal 9, goal 11, predictive maintenance, goal 12 and goal 9, effective energy efficiency, goal 7 and goal 13, and consumer energy management, goal 7 and goal 13 and goal 12. So basically, it's now let's go to my university role and such things. So AUS, American University of Sharjah, is playing significant role in the COP 28, which is going, this is where we are now, and this is the theme for our talk and other talk, and I'm sure you are enjoying the COP 28, which is the United National Climate Change Conference. And here are some of key aspects of my university involving participating in the COP 28 discussion and exhibition, co-host the Global Conference of Youth, leadership in UAE University discussion on climate, member of the COP28 University Task Force, part of the University Climate Network. And this is here also what we have, role of our university in the climate action progress, economics, sustainability. The economic sustainability, Dr. Bayan, my colleagues working on this. Other colleagues, they are working in electric vehicle and robot. Me, I am working in the smart city fostering sustainability. Dr. Mustafa and his team, they are working on AUS renewable energy. Other faculty working on the recycling. Dr. Samir is AUS professor working in the sustainable innovation. Another group working in thermal energy advancement, and some they are working in big data and solar energy farm. Dr. Dawoodi, Dr. Zulqarnain, and Dr. Habib here, Dr. Shayuk and Ms. Salsabil. They published a lot of paper on this, and this is my presentation.
Alrighty, thank you very much, Professor Ali. Right. The next speaker that we have is Dr. Yang Jing, Singapore R&D Head of Lite-On Technology Corporation. Her research development include energy management system with advanced AI algorithm, EI smart charging, management system, and smart home solution with renewable energy and battery storage. Her topic will be covering carbon reduction and IoE solution. Okay, back to you, Yangjin. You can start. I think you need to unmute yourself first.
Thank you so much, Kelvin, for your introduction. Yeah, now I share my screen. Okay. Okay, yeah, sorry. Okay, entire screen. Okay. Share. So, can you see my screen? Hello? Hello? Can you see my screen?
Yes, we can see your screen.
Okay, that's great. So,
Wonderful. Yeah, it's okay.
Yeah, that's great. Good afternoon, everyone. My name is Yang Jing. I'm R&D head of Lite-On Singapore in efficient infrastructure. So very glad to have this opportunity to share with you about our Internet of Energy solution and how we can help customers to reduce the carbon emission and to achieve the sustainable energy future. So in the center of this chart is a global greenhouse gas emission by sectors. This is published by the World Resources Institute in 2020. So, and on the two sides are the key enablers which can help us to achieve net zero emission. So, for example, this renewable energy such as the solar PV and wind is very important to reduce carbon emission, and also to increase the energy efficiency and enable the green transport such as the electrical vehicle as well as the hydrogen vehicle is also to help to reduce the carbon emission. Besides that, the softwares, which is the energy management system, as well as the artificial intelligence technologies, can be used to further optimize the energy usage and reduce emission. On the other side, the green material carbon management platform, as well as the carbon offset and carbon trading platform and market, will also help us to achieve the net zero emission target. So we're back to this graph, which is the global greenhouse gas emission. So we can see that this energy, contribute more than 70% of the global greenhouse gas emission. And it will be very important to address the energy cost carbon emission. So how? So we use this Internet of Energy technology, which is connected to the different renewable energy resources and energy devices, as well as the softwares to reduce the carbon emission and at the same time to improve the energy security and to enable the grid resilience and flexibility. Then we zoom into how to achieve the net zero emission by using IoE. So we can see that actually reduce the carbon emission, the renewable energy such as the solar, PV, wind turbine, hydrogen is very important. However, all these renewable energies will cause the instability or power quality issue of the power system, and also they will have the uncertainty due to the weather information or condition information. This is one side. And on the other side, so this buildings, residential load, or even microgrid load, they also become flexible, and they will integrate solar panel. They will integrate the EV charging infrastructure. So it will change the traditional consumer to the prosumer, or it will change the traditional one-way power flow to directional power flow. So this uncertainty or change of the power system will give the challenge of the system, so that in order to enable the integration of the renewable energy, as well as to increase the penetration of the renewable energy, we have to use the solutions such as energy storage to compensate the impact and to stabilize. However, energy storage is very expensive, right, at this moment. And then we have to find an economic way to how to do the sizing, how to do the optimized operation, as well as when we should do the operation. So there should be a system, we call it the Internet of Energy, connect all the devices, equipment, information together, so that we can know when and how we can optimize and coordinate the devices and dispatch, so that we can satisfy the energy requirement and to achieve the net zero emission target, and at the same time to improve the grid resilience, flexibility, and to allow more efficient and reliable energy system. So this is why we use this IoE solution, and this is plays a very critical role to achieve the net zero emission. So next one is the LEAN Internet of Energy solution. So LEAN is committed to developing and implementing innovative solution to reduce carbon emission and also to achieve the sustainable energy future for customers. So our solution includes variables scenarios, which including this residential or home solution, then to the smart building solution, data center solution, as well as EV charging solution. On top of that is the smart grid, so that we rely on strong technical and manufacturing capability on the power supply, EV charging, EV charger, and also the automotive LED light. So we also have 5G solution, so that all this existing our capability, as well as our advanced energy management solution, can provide a total solution to the customer to reduce carbon emission, provide a cost-effective energy solution to the customer. So this total solution will help the customer to optimize the energy usage, to enable the seamless monitoring and control of energy devices, as well as backup the power supply when the system has, when the power grid has emergency outage. So this is of our IoE solution can provide. Okay, next one is actually our IoE solution is interconnected EMS ecosystem. So we have a residential energy management system, building or CNI energy management system, microgrid energy management system, as well as a smart charging solution. So each of the solution or energy management system, they are connected to the local devices, such as smart meter, solar PV, energy storage, building equipment, or the EV chargers. So they connected the devices at edge level, and then they either to do the data processing either at the edge using edge processing, or it's send all the data to the cloud to do the centralized analysis. So that is a flexible solution, and to do the monitoring and control. So some of the solutions, they only stop at the monitoring, and some of them is advanced, is have a analysis capability. However, our solution not stop there. We do the closed loop control, so that if you only do the monitoring, that is only status visibility. However, in order to reduce the carbon emission or to provide a cost-effective solution, we have to do the control. So the control part, we will have the advanced AI machine learning optimization algorithm as well as forecasting algorithm to do the forecasting of the solar PV generation, forecasting of the consumption load, as well as the energy price, so that we can do the optimized scheduling of energy storage as well as dispatchable load, so as to reduce the emission as well as reduce the energy cost. So we have a solution to apply different scenarios, and we start with the residential energy management system. So this energy management system includes hardware as well as software. So the solar PV, the hardware are the solar PV, battery energy storage, smart panel, EV charger. And the software is our EMS software, which can do the real-time monitoring, analysis, control, as well as optimization usage. So for this EMS, we have the software which enables the mobile app as well as web page, so that the homeowners can use mobile app to monitor the real-time status of the energy generation as well as consumption. So we also have this smart panel, which enable the next level details of the smart meter, so we can know each individual appliance how much energy consumption, and if you have the emergency mode, for example, there's the outage of the power grid, so we have to reduce the energy consumption. We can shut down some of them, for example, the swimming pool or the water heater, but then keep the fridge. So this is the flexibility we can provide to the customer. We have the test bed in Singapore, so that this is a household. It's a bungalow, and the energy usage per year is around 20 kilowatt hour. And then they have installed a solar PV panel, which is generated 30,000 kilowatt hour per year. And so that by using this solar panel, this house is use green energy to power the house by 64.1%. So more than 50% of the energy used by this house is solar PV. And we also use this energy storage to promote the two mode. We have the two mode. One is economic mode, another one is green mode. So for the economic mode, our optimization objective is to reduce energy bill. And for the green mode, we actually our optimization objective is to reduce carbon emission. So for example, we can during the daytime, we do not use the energy consumption from the power grid. We use the green energy solar panel to charge the electrical vehicle, so that we can push the green energy usage. So this is how our solution help the customers. So in the summary, we hope we understand that achieve net zero emission is becoming a common goal for governments, business, and individuals across the world. And we all have a role to play in and make it real. For the Internet of Energy, it facilitates the usage of the energy storage to help the customer to increase the penetration of the renewable energy resources. And it also enables meet the energy requirement while reducing the dependency on the fuels and lower the carbon emission. For the LightOn, we have a vision on achieving global carbon neutrality and providing sustainable energy solution through the IoE technology. We start from residential solution. We are excited to collaborate with partners and stakeholders to bridge the gaps of IoE and towards a cleaner and greener future. Okay, thank you.
Well, I would like to thank young Professor Dr. Yang Jin for her presentation. Fully aligned on achieving net zero carbon emission require everyone play a very vital role. Together, we can definitely hope to achieve that. For our next speaker, we have Professor Xu. He is now an associate professor at the School of Electrical and Electronic Engineering and a cluster director at Energy Research Institute at NTU. Dr. Xu, his research group are focusing on stable control of renewable energy power system, microgrid, distributed energy resource integration, and data analytic for smart grid application. Today, he will be talking about AI-based smart home energy management toward carbon neutrality. Okay, Dr. Xu, you can start.
Okay, thank you. Thank you, Chairman, for your kind introduction. Let me share my screen. Can you see my screen now?
Yes, we can.
Hello, good evening, everybody. This is Yan speaking from Singapore as well. Thank you very much for having me here in this session today. And it's my great pleasure to talk about our research and development works on the IoE solutions to combat climate change. So today my topic is on the artificial intelligence-based smart home energy management towards carbon neutrality, which is actually based on a joint research project between my university and the Liteon company. Part of this work has been just introduced by Dr. Yang in her presentation, while in my slides, I may provide more technical details about this developed energy management system, as well as some simulation results. Okay, so here you can see the outline of my presentation. First of all, I will give you a general introduction to the background about the residential energy consumption. And after that, I will describe the research problem, including the flexible appliances, as well as the need for the home energy management system. And in the third part, I will introduce our technology development for this so-called AI-based smart home EMS. Okay, so according to International Energy Agency, the residential energy consumption makes up more than 26% of the total electricity consumption in the world, which contributes to around 17% of the global carbon emissions. Therefore, the residential energy consumers can play a very important role for carbon reduction, as well as to achieve the so-called carbon neutrality. So here are some statistic numbers. You can see that for the electricity, natural gas, residential energy consumers make up more than around 1/4. Yeah. Okay, so in fact, the residential households have great potentials to reduce the carbon emissions. On the one hand, the renewable energy resources that produce zero carbon emissions, such as the solar PV system and the wind turbine, can be installed at the household site, which can provide the local and the clean energy to the consumers. While on the other hand, many households have switched to electric vehicles, or they are equipped with residential batteries. And these new resources also have a great flexibility to accommodate the renewable power generation, which is always stochastic and fluctuating. And this figure is an illustration of the daily power consumption profile of a household with rooftop solar PV system. And you can see here, during the daytime, when the solar PV produces much power, the household does not need to draw electricity from the power grid. Instead, they may even send the power back to the grid. So With these new resources at the household site, we will be able to better manage the residential power demand as well as the power supply. And the benefits are very clear. So for the users, through this home energy management, they can achieve lower electricity bills, save money. And for the utilities or for the whole society, through this home-based energy management, they can achieve, allow more utilizations of the renewable energy resources, which can contribute significantly to the carbon reduction and the carbon neutrality target. Okay, so specifically, the home management can be realized by controlling the home appliances with certain flexibility. So generally speaking, the flexible appliances can be divided into time shiftable and the power shiftable appliances. So for the time shiftable, that means the energy consumption of these appliances can be shifted from one time period to another period. For example, the washing machine, the EV charger, as long as we can satisfy the total power consumption, it does not matter, we can shift the time consumption timing. So this is called time shiftable appliances. The other one called power shiftable appliances, which means we can adjust the power consumption without significantly affect the customer's comfort level or convenience, such as the air conditioning. We can increase several degrees of the temperature without affecting the customer's comfort. And also we can adjust the lighting strength in the household level without affecting significantly the customer's convenience. So that is called time shiftable. So the home energy management system aims to optimally manage these flexible appliances in order to achieve the maximum usage of renewable energy resources or minimize the total user electricity bills. So that is the general purpose of this home energy management system. Now, clearly, this home energy management is a very complex and technically challenging decision-making problem. In order to do this, we firstly need to accurately model the behavior of the appliances as well as the user patterns. And also, we need to measure the status of the appliances and monitor their status, including on and off, as well as their power consumption. And besides, we also need to predict the future local power generation from our rooftop solar PV or small wind turbines, as well as the future electricity price, and certainly our future energy demand. And finally, we need to optimize the schedule of these appliances without significantly affecting consumers' comfort and convenience. So in the past 2 years, we have been collaborating with Lite-On Corporation to develop a so-called artificial intelligence-based smart home energy management system, AI HEMS for short. So here, this is a general framework of this EMS. So basically, our smart home is connected with the power grid, drawing the electricity from the main grid. And in the meantime, the smart home may be installed with solar PV, and they may also have residential batteries, as well as electrical vehicles, as well as the flexible appliances. So the key part of this EMS is on this decision-making controller, which is based on the artificial intelligence algorithms. So next, I may give you more technical details about this system. So here, this is the general architecture of the developed system. There is a centralized platform that takes input from the local power generation from the rooftop or small wind turbine, as well as the electric vehicles, residential batteries, and the electricity price, and even the power grid control signals sent to the smart homes. And also, we take the measurements, monitoring the smart home appliances, as well as some other information, such as the lighting, the temperature, so on and so forth. And the algorithms based on the artificial intelligence will optimize the electricity schedules of the appliances for different periods of a day. And then the control signal will be sent back to the appliances to control their operating status. And look into this system. So our EMS will analyze the load behavior to evaluate which appliances can be controlled for the next interval, and then determine the on and off status of the appliances for each hour, as well as their consumption. And but in this process, it's very important to make sure that the user's comfort level and convenience are not significantly affected. And certainly the whole system is a very complex, continuous decision-making process. And in order to efficiently solve this problem, in this project, we have developed artificial intelligence-based optimizer based on the so-called deep reinforcement learning. I guess many of you have heard of a deep reinforcement learning. If not, I suppose you may heard the AlphaGo, which is a very famous computer program that have beaten the world-class chess player. But actually, the core part of the AlphaGo is also based on this deep reinforcement learning, so-called DRL. Well, the technical principle of the DRL is that we need to train a decision maker, which is called agent, through the iterative interactions with the environment. And during this interaction, the agent will make actions that will change the environment, and the environment will return reward to the agent. And clearly, the agent wants to reinforce itself in order to have more and more rewards. That's why it's called reinforcement learning. Well, in order to, apply this deep reinforcement learning to home energy management, we need to model the problems correspondingly. For example, the agent in this context will be the appliances controller, and the environment will correspond to the smart home. And the status, actions, and reward will be correspondingly modeled in the relative context. And so this is some illustrations of our developed HEMS for the web-based graphical user interface. Here you can see we have a web-based login page. We have this dashboard. We have different control panels, and we can monitor the household energy consumption, predict the future generation, as well as the demand, and also the electricity price. And then we can make the electricity schedules for the appliances. And next, I would like to show quickly some of our preliminary testing results through simulations of realistic data sets collected from different parts of the world. And we have tested different scenarios to demonstrate the effectiveness of this HEMS for saving energies and electricity bills. You can see that for the daily energy saving, we can achieve around 20% with the AI-based HEMS from the traditional non-controlled home energy consumption. And for the whole month, 30 days, our average saving can be up to around 18%. And the two figures in the bottom compares the difference between the controlled energy consumption and non-controlled energy consumption. Clearly, you can see that the power consumption profile is a bit different. However, I want to highlight that through this power shifting, the user's comfort level and convenience are not significantly affected. So this is some of our preliminary testing results. Okay, so I would like to finish my presentation by showing this aerial view of our university campus. Our university NTU is fully committed to carbon reduction. As you can see, we have installed a rooftop solar PV system in most of our buildings. And many of our buildings are already Green Mark certificate. I think in the future, in addition to the residential buildings, there will be also great potential commercial buildings to contribute the carbon reduction. So I think the developed HEMS can also be extended to these application scenarios. Okay, that's all for my presentation. Thank you.
All right, thank you very much, Professor Xu, for your sharing. I definitely are very excited to hear that through your AI algorithm and then also certain research that you can actually achieve further saving of 18% compared to the previous household owner electricity usage. I think that is definitely a very positive note on that. For our next speaker, Anita, she is, give me 1 second. She is the strategic planning manager of NextDrive. And NextDrive is actually was founded in 2013. NextDrive had a vision of creating lifestyle that optimizing consumption of every power via Internet of Energy, IoE technology. With that, let me have her start her presentation on energy perspective to carbon neutrality. Anita, you can start.
Okay, let me share my screen. A sec. Okay, hi everyone. I'm Anita Jen. I'm a strategic planning manager of NextDrive. I'm in charge of global business strategy and development. And it is my great honor today to talk about the energy perspective to carbon neutrality on behalf of NextDrive. So in NextDrive, we believe that technology plays a crucial role in the net zero roadmap. And there is nothing more exciting for us to see the world and the society move forward with the power of technology. With IoE, the Internet of Energy, we launched a series of distributed energy resources management solutions. We support all those who aim to reach their sustainability goals with a seamless energy transition. And how do we make this ideal scenario come true? Firstly, we build up this IoEM platform. This is our product. It is an Internet of Energy platform that offers an easy gateway to for everyone to get the energy data for who wants to establish their new energy services. We make all energy devices deployed at a site, easily monitored and even controllable with our strength in hardware and software integration. Secondly, we believe that data management, analysis, and also powerful computing are actually the core of our IoEM platform. So with the capability of data computing and processing, we enable the realization of our IoEM platform. With the capability to do that, we think that no matter it is a solution for zero energy house, or it's an energy management system, or even a microgrid, all those solutions can be realized and implemented on different sites. So you can find all that you need from our IoEM platform to quickly be on track to reaching RE100 or reduce your carbon footprint and even more. So it seems like very too good to be true. So, well, we think that it is really not something that's far beyond reach anymore. So let me give you some examples. These are our solutions providing for all different type of fields. We've covered home solutions and also applications for chain stores and even factories and commercial buildings. And on the city or municipal level, we help everyone to be aggregated and forming a virtual power plant. So let me start from our home solution. Okay, with our home energy management system, households in Japan, they can effortlessly just build up their own zero energy house. What they do is that the user can easily use our app, and then they would be able to connect the smart meters at their home and also the solar panel on top of their rooftop into the system so that they can monitor the power generation and also at the same time checking the consumption from their like hot water boilers or some heavy electricity usage equipments. But also at the same time, they know how much they are using and balancing it with the home battery system at their home by discharging the battery. And in Taiwan, there's a completely different story because in Taiwan, usually the low voltage users, they won't be able to get real-time data because it's not available in the market. And we have only one utility company, and they haven't been able to provide this type of real-time data for every user. So in our solutions, we provide our communication module and then put it in the smart meters of Taipower so that each household or homeowners, they can easily get the real-time data. And then they would be able to know the electricity consumption pattern. For that, then they can finally know what are the peak times that they are using the electricity and what are the times that they use less. And then they would be able to take actions. So based on our analysis of over almost 2,000 households in Taiwan that is already using our solution, we noticed that around, in average, 3% to 5% total electricity bills can be reduced. So which is quite a good result. But also one of our heavy users told us that he managed to reduce 30% of his monthly electricity bills just by noticing something weird from our solution that he finally found out that it's actually his hot water boilers that would be reheating the water in every 3 to 4 hours. So what he did is that he buy it's actually a timer for the hot water boiler, and then to set it to not boiling off the water in every 3 to 4 hours. So this is really a very small action that he took, but it creates quite a huge impact for him. So this is something that we provide for the homeowners. And then for the chain stores, based on our kind of client interview with our users, we get the most challenging part for those chain stores is actually the headquarters. They won't be able to get the accurate and even timely data from all these different stores because the store managers have a lot of things to do. So every month, whenever they have to report back how much electricity consumption they have for the past month, sometimes it would take quite a long time. And then all the members in the ESG group at the headquarters, it's a very hectic task for them to do it every month. So that by installing our solutions, the headquarters staff, they can easily just monitor the electricity consumption of each stores. And then for each stores, they can easily monitor their usage, but also while at the same time, they can set alarms whenever there's a abnormality in the electricity consumption that they think that it shouldn't be there. For example, like if a store closed at like 10 p.m., then if they see there's a electricity usage at around maybe 12 at a midnight, and then they probably would know that there must be something that they forgot to turn off when they get off work. So this is something that can help them to manage their electricity well. And there's even one additional advantage for them, because based on our communication with them, we noticed that most of the store owners, they don't really understand that basically the utility is not as a percentage of their monthly revenue. You always would think that the total electricity bill would probably be like 1% or 2% of their monthly bill. But after installing our solutions, they noticed that actually sometimes the monthly bill in terms of electricity wouldn't really change because the pattern of using the energy doesn't really be in accordance to how they sell, how the sell in the store is. So because of that, they know how to use the data from our solutions to help them with their annual budget. So this is something that we even never really thought about, and then we found out that it's actually quite important for all the chain stores. And later on, we also have implemented our solutions for manufacturers and also some of the factories. So what we know that for those factory managers, they have to do a lot of daily report because they have to follow up with their daily performance on the for the previous day. So that in order to manage that, they in the past, if they don't have any smart solutions, they have to hire a lot of staff just to walking around the factories, reading all the meters of these different equipments, and then write it down, and then input it into an Excel sheet. And that would create, well, we would say that it would create quite a lot of work for some staff, but it's really inefficient. And most of the time, it would the factories will usually know that they probably would get some data wrong because it's all manually inputted. So by installing our solution, they can have this real-time data, and also it's accurate. They don't have to do a double check or even triple check for the data. And then all the data would be recorded at a specific time frame so that when they are doing the data analysis on the daily basis or periodic analysis, it would be easier to get all the precise data. And then we know that most of the factories they want to implement this smart solution is basically they all have their ESG goals. So to reduce their carbon footprint, they have to know exactly on each production line how much electricity they are using. So our solution also help them with that to incorporate it with their own ESG goals. And lastly, we also have established solutions for commercial buildings. Basically, for all those commercial buildings, because they don't have a huge rooftop, so to install a really big areas for PV panel is not something that's well, it's not available for them. So what they can do is to basically buy green energy from the retailers. Well, basically that's the story in Taiwan. So we help them to firstly, because they have to inevitably they have to buy green energy. So the first thing we would help them is to buy installing our solution. They can know how much they are using and also what are the peak hours that they are using the electricity, and then they would know how much electricity they have to buy from the green energy retailers to match their demand load. And so we would help them to optimize their energy consumption behavior. And also we would help them to do further analysis. It's a data-driven action to uplift their RE percentage. Because basically it's really difficult to buy renewable energy based on, it's 100% would be suited with the power consumption at a commercial building. So they have to buy renewable energy in different phases. But to increase more and more RE percentage, it will be even more difficult to know how much they have to distribute in terms of those renewable energy. So that's something that we would help them. And for all those previous solutions, we believe that actually what we are doing is that we help everyone, no matter which sites or which type of fields that they are in, they can make the best use of every kilowatt hour for them, so that they can manage their own electricity well. And then later on, they would know that basically by only just adjusting the electricity consumption, they can actually provide resources for the total grid. So by combining all those different sites into one virtual power plant, it can create a larger scale of virtual power plant to support the grid, so that everyone, because at the end of the day, everyone is connected to the grid. So we have to do all we can do to support the grid, make it resilient, even sustainable. And we believe that, well, basically everybody can benefit from it. So that's the goal that we want to reach at the end. But to form a virtual power plant, it still needs to be starting from one side. And how we are going to help our clients to manage their electricity well and in their own sites, we believe the power of data. Well, basically, this graph that you can see is the real data form graph from one of our clients. So from this page, you can see that this is our real-time data computing and simulation So we will predict how much solar power is generated from the rooftop. And also we would predict how much electricity they probably would need to use. But also at the same time, we have to consider whether they are breaching their contracted capacity so that they would have to pay penalties to the utility. We want to avoid this type of scenario. So based on the real-time data and also our computing capability, we would determine on which time our energy storage system needs to be discharged. And also by uplifting their RE percentage, we also will determine what time our battery needs to charge so that there won't be any surplus solar power to send back to the grid. So this is something that we help our client do. And then we also put it in front of our solutions so that we believe that everyone who already have some budget and they spend money, made the investment to install this comprehensive solutions and also all those different type of equipment, they want to see the results. So we believe that we provide them with the efficacy that they can see easily on our solution. So to sum up, this is my last slide. What we want to offer is that basically we have the real and effective net zero solutions. We believe by using our IoE platform, and we can help everyone begin with the essential infrastructure for this new energy era. And you can see this is basically all the areas that is already installing our smart gateways in Japan. And there are already more than 35,000 gateways launched in Japan, only just in Japan. And we believe that we believe that everybody can starting to manage their energy well and also be on track of their sustainability roadmap. So by using our solutions. So this is all of my presentation. So thank you for your attention.
Well, thank you, Anita, for the wonderful presentation and your sharing. I'm very happy to learn that there are 35,000 plus of gateway are deployed in Japan. So, which means that Nextra is actually very helping Japan and also Taiwan as well to improve the carbon footprint reduction. On that note, I think the next session will be our panel discussion. Okay. I believe that Dr. Peng probably will need to excuse himself a little bit earlier. So my first question is toward Dr. Peng, right? Based on what have you just learned, right? What do you think about IoE, and then what do you think the IoE can bring to this sustainability journey?
Hello. The
Hi.
questions. Hello. Sorry. The signal is not good right now, and so probably maybe you to the others. Yeah, it's okay. Can you hear me? Yeah.
Yeah, I can hear you just fine.
Okay. Because just signal is not stable during the last 10 seconds.
Okay,
Sorry.
no problem.
Yeah.
Would you like me to address the other speaker first, or do you want me to repeat the question again?
Oh, repeat the question again, please.
Okay, so my question to Dr. Peng is that based on what you just have learned about IoE, right? And what is your opinion? What do you think about what impact IoE can bring to this to the sustainability journey around the globe?
Okay, I recommend probably in this COP there were lots of the new development in the green zone, and a lot of people visit the green zone. They found lots of innovation. So such is kind of IoE. I found did not talk too much here. So I recommend probably we can keep going of such as kind of topic, especially the IoE energy. And by my point of view, because I'm a meteorologist, and we forecast the solar PV and offshore wind farm every day, and the accuracy is quite good. And just I know in the future, in every home and every buildings, we need the IoE. It's good for saving the energy, and however, it still takes time. For example, the standard and also the data sharing, and also any kind of information sharing is a problem. So today, some of our speakers also talk about how to share the data in one enterprise or in one buildings, how to share, to collect, and all of the data collected together by using the AI can do something better for the IoE. So I think digital cross-screen, that means we should combine together. So I think such as kind of topic, I recommend Lai Ang should be our leading to talk about IoE. And that's very important in the future. And I recommend probably we can do it more, especially in the COP. Maybe next COP will be in East Europe, and we can continue to discuss about that. And Kevin, sorry, because I was recruited to move to another Acer session. They have an opening here. They have a week here. So I will give the floor to you.
Okay, sure, no problem. Well,
Thank
thank
you.
you very much for your participation with us.
Yeah.
Okay. Okay, so my next question, I will ask Dr. Yang Jing, right? In your presentation, you mentioned that some of the current solutions are quite expensive. For example, the battery. Right? From your perspective, how can we ensure that renewable energy and green technology are accessible and affordable for people are in both developed and developing countries?
Thank you, Kelvin, for your question. So actually, I repeat your question is how to make sure that both the developing and the developed country can afford for those renewable energy solutions, right?
That's correct.
Yeah. So honestly speaking, the developing renewable energy solutions price dropped a lot in the past 20 or 10 years. So for example, for the PV price, it's a drop in 2007 is around $4 per kilowatt. However, in 2021, it's less than 50 cents. So this is more than 10 times of the dropping of the price during the technology innovation as well as the capability of manufacture. So that we understand that different timing is very important. So if I think not every technology is sustainable or is economic for a purpose, so that maybe different countries may choose to use this renewable energy at different timing. And this is one part. Another part is about government subsidy. So actually I think the government subsidy in the solar industry previously in Europe country, that is more than 10 years before, and also in Japan, in Hong Kong, also in US, there are a lot of government subsidy. However, for developing countries, I don't think they have enough government subsidy to push those renewable energy resources. And then next one will be energy trading, energy import, export, as well as carbon trading. So actually, this part will enable the developing countries to export the energies to the country which the energy price is higher, so that this kind of trading platform will help the developing countries to get some more incentives to promote renewable energies. Yeah. Thanks.
Okay. Thanks for your remarks. Certainly, we do need government support to actually promote this renewable energy while the cost is still very high. My next question is for Professor Xu, right? Besides AI and deep reinforced learning, what other technology innovation that you will see to address the challenge and accelerate the pace of IoE development and implementation?
Okay, thank you. Thank you, Chairman, for your question. Personally, I think in the future, one of the major important concern is on the safety and the privacy of this IoE application, in particular at the household level. For example, if we have smart meters that can collect the customer data and communicate with the utility site, and the privacy concern will come in. And given these widely deployed edge devices, there may also be cyber attack risks. For example, the attacker may inject the false data into the system and mislead the customers and even utilities. So I think these are quite important concern for the next phase of this IoE deployment. And so in the future, I think if we're talking about artificial intelligence, we certainly need to consider this robustness of this artificial intelligence technique. How do we guarantee the safety of these AI algorithms, and how do we protect the privacy of the customers? So I think maybe in the future, more efforts need to be devoted in this regard. Not to mention that there may also be some acceptance issues by the consumers, because for some of my let's say my colleagues and my students, they are actually very reluctant to install these smart meters in their household level because they may release their privacy. So I think how do we educate the customers in this IoE area is also an important issue. Yeah, that is my personal views. Thank you.
Yes, I fully agree. Typically, the technology advancement are much faster than what the market adaptation is. So education definitely plays a very key role in deploying IoE. So on that note, my next question for Anita, since that you already have your Nextdrive already have a lot of experience deploying similar solution like IoE to Japan and Taiwan. It's actually two questions. How does Nextdrive tackle the privacy concern, and especially on the cybersecurity upfront, right? And then follow-up question will be, what are other key challenges must be overcome to successfully implement a digitalized, decentralized energy system? And then how can it be addressed from Nextdrive's perspective?
So there are two questions, right? The first one is in accordance to the cybersecurity. Well, basically what we can do is that to follow up all the international cybersecurity standards. And we have actually one real case. At the beginning, when we just entered Japanese market, there is actually one utility company asking hire a group of hackers to hack our gateway, and by passing that task, we finally get a POC project with them. So basically, what we can do is just to follow up all the like ISO 27017, something like that, to increase the cybersecurity aspect of our solutions. But we believe that also by in the foreseeable future, because there will be a lot of different type of gateways installing at all the sites. And as I just mentioned earlier in my presentation, we aim to help everyone to be able to control their devices. So the cybersecurity would be a key issue in the future. And I think what we can do is just to do our best I'm sorry, I don't have a better answer for this one, but well, we believe that that's the feature that the challenges that we have. And as for the second questions about the challenges that we also facing in order to implement a digitalized, decentralized energy system, and also how these issues can be addressed. Basically, based on our experience, we think that the advocacy from those international organizations is quite important. And also, at the end of the day, why those site owners have to do this investment to implement all this different type of equipments and also the solutions. Why they want to do that? Well, at the end, it's either the government has subsidies or the government has penalties toward this. So we believe that by keep following up with the regulatory framework of each country in terms of the energy transition is quite important in terms of how this decentralized energy system can be realized. And then beside this, on the local level, we notice that basically because all our solutions are on the cloud-based, so the cloud service, the architecture of the cloud service, how can incorporate different type of systems and different type of communication protocols to work together in one single solution. That itself is already quite difficult to tackle. And then beside this, the electricity diagram in each site are different. So while we now not just realize, but we always have this in mind that this is a solution that's combining the power of information technology and also the electrical engineering. So it's not something that you can easily find one expert to tell you how you can do it. So this is something that you have to hire a group of people and then listen to each expert in order to incorporate a best solution for each site owners. So we think that the continuing education for those site owners, letting them know that this is not something that's very easy. You only need to install the software and everything can happen. This is completely not the story. So we have to do a lot of work educating or learn with our client. This is something that we have to do, and also we have to incorporate different the experts from different fields to form a solution that's beneficial for everyone. So this is something that we think that are the key challenges that we have and still we're probably facing in the next 2-3 years and so on.
Got it. Got it. I think that definitely we do foresee a lot of challenge moving forward, but I think we have a really great cause to overcome that challenge so that we can all achieve the net zero emission target, right? I think this will be a long journey, and then I also echo your point of view on government does play a very vital role, either with the carry or the stick approach, right? You either give subsidy to incentivize or you get penalty. But either way, I think this is something that we need to work with our local government on that, on the policy. I think we only have 1 minute left, so I think let me on behalf of Lydon, all right, I would like to express my gratitude for all the exceptional speaker and attendee who joined us from different corners of the world for this virtual COP28 session on emerging technology to tackle climate change with IoE solution and the panel discussion. I sincerely hope that you pick up some valuable insight from the section and are now inspired to develop deeper into IoE solution and take meaningful action toward achieving your net zero emission goal. And remember, we are all in this together, and all our collective efforts are crucial in combat climate change. So let us work together toward a better, cleaner, and sustainable future for all. With this, we'll conclude this section. Thank you very much for your time.
Thank you.
That's
Bye-bye.
it. Thank you.
Thank you. Bye bye.
Take care. Bye.